All right, for this lesson, we're going to take a look at addition and subtraction of rational expressions. So if I was going to add or subtract a fraction, and remember rational expressions are just more complex forms of fractions, then the first thing I would do is I would determine the lowest common denominator, or LCD, for the rational numbers. I'm going to express each rational number as an equivalent rational number with the LCD as the denominator. So figure out what I need to multiply the numerator and denominator of each fraction by to make the denominators match. And then I would just combine by adding or subtracting just the numerators, because as long as they have the same denominator, the denominator is going to stay the same. And the last step is I would try and reduce if it is possible. So if I'm doing this process with just basic fractions, then I would take a look at 2 over 3 and 2 over 5, and I can see that I have denominators of 3 and 5, which means that the lowest common denominator is going to be 15. So I would need to multiply the first fraction by 5 on the top and on the bottom, so it's an equivalent fraction. I'd need to multiply the second fraction by 3 on the top and the bottom, so it's an equivalent fraction. When I do this, if I take 5 times 2, I'm going to get 10. And when I take 2 times 3, I'm going to get 6. And because they're going to have the same denominator of 15 now, I can say that it's all over 15, because I'm just combining the numerators. And then I'm going to add the numerators and get 16 over 15. I'm going to do the same process for the next one. I'm going to say, well, when I take a look here, what is the lowest common denominator between 6 and 4? And that's going to be 12. So I need to multiply the first fraction by 2. I need to multiply the second fraction by 3. That's going to give me 10. Be careful because there's a minus here, so it's going to be minus 1 times 3 is 3, and that's all over that LCD of 12. And if I take 10 minus 3, that's going to give me 7 over 12. Now I could realistically do this with any number of fractions. When I get to the last example here, I have 3 different fractions. So I need to look at the 8, the 3, and the 12 and say, what is the lowest common denominator between all 3 of these things? And the answer is 24. So I need to multiply the first fraction by 3. I need to multiply the second fraction by 8. And I need to multiply the last fraction by 2 so that they all have denominators of 24. And I can say that in this case, 3 times 7 is going to give me 21. There's a minus between them, so I need to account for that and say that I'm going to subtract. 2 times 8 is 16. There's an addition for the next one, so I'm going to say that I'm going to add 5 times 2, which is 10. And it's all going to be over that common denominator of 24. When I take 21 minus 16 plus 10, that's going to give me 15 over 24. And unlike in the previous cases, there is a common factor between 15 and 24. That's 3. So I can reduce this fraction down to 5 over 8. And there's going to be my final answer. When I'm doing this process with rational expressions, our process is actually pretty similar. So we can take it with a non-variable denominator, which means that it's just constants in the denominator. There's no actual variables that are going to be included, which makes the process a little bit easier. Because then, just like in the previous examples, I'm just looking for what is the common multiple between numbers, or the lowest common denominator. So if I have 4, 5, and 10, then the lowest common denominator is obviously going to be 20. So I'm going to multiply the first one by 5. I'm going to multiply the second one by 4. And I'm going to multiply the last one by 2. And this is going to give me 5 times 3x is 15x. There's a plus in between, so I'm going to say plus 4 times x is just 4x. There's a minus in between. We got to be careful of those. And I'm going to say that's going to be minus 14x. And this is all over that LCD of 20. When I combine the numerator, I'm going to wind up with 5x's over 20. And I can divide the numerator and denominator by 5. Which is just going to give me x over 4. Now when I get to the second example, or b, I see that I actually have binomials in the numerator. Which means that when I'm going to multiply the fraction, I need to multiply it into the entire binomial. And the way that we do that is anytime I see a binomial, I'm going to put brackets around it. And this is going to indicate to me that I need to expand whatever I'm multiplying in into both terms that exist in the top. So when I look for a common factor, or lowest common denominator, between 3 and 6, it's going to be 6. So I'm going to multiply the first fraction by 2, and the second fraction is going to stay the same. I'm just going to actually multiply it by 1. It's not going to change. Which means that now what I have is I have 2 3a minus 1s plus 1 4a plus 5, and that's all going to be over 6. I'm going to expand it out using the distributive property. And that's going to give me 6a minus 2 plus 4a plus 5 all over 6. And when I combine my like terms, the a's with the a's, the constant with the constant, I'm going to have 10a plus 3 all over 6. And there's my final answer. When I get to example C, same process. As soon as I see these binomials, I'm going to put brackets around them to make sure that I do it properly. The common denominator is going to be 24, so I need to multiply the first step by 3. And the second one by 8. And that's going to look like 3 8y's minus 3. Be careful because there's a subtraction here. So I'm going to say minus 8 2y plus 1 all over 24. And when I expand this, make sure that you're multiplying both these terms by negative 8, not just 8. That's going to give me 24y minus 9 minus 16y minus 8 all over 24. And once again, when I combine the like terms, I get 8y's minus 17 all over 24. And there is my final answer. Anytime I wind up with a term that doesn't have a denominator, I just need to remember that's the same as it being over 1. And then my process is exactly the same as what we've previously been doing. Put brackets around the numerator if there's more than one term. The common denominator between 2, 1, and 8 is going to be 8, so I'm going to multiply the first set by 4. The second one by 8. And the last one by 1. This is going to give me 4 bracket 7x plus 3 plus 8 times 3 is 24x minus 1 bracket x minus 3. All divided by 8. I'm going to expand it out, and I'm going to get 28x plus 12 plus 24x minus x plus 3 all over 8. And when I combine the like terms, the x, and the x is going to give me 51x's. And 12 and 3 is going to give me plus 15. All divided by 8. And there's my final answer. For example B, between 1, 9, and 3, the lowest common denominator is going to be 9. Put brackets around the numerators if we need to. I'm going to multiply the first one by 9, the second one by 1, and the last one by 3. This is going to give me 9 times 4 is going to be 36, minus 1, y minus 4, minus 3, 5 minus 3y's, all over 9. When I expand it out, I get 36 minus y plus 4 minus 15 plus 9y all over 9. When I combine my y's, I have 8 y's. And when I combine my constants, I have plus 25 all over 9.